Today we will do the questions on page 459, section 13.2. The way we will do these questions is I will read out the question first and then explain the answer. The final answer will be displayed in a green font. So question number 31. Explain why Avogadro's principle holds true for ideal gases that have small particles and for ideal gases that have large particles. Now, Avogadro's principle states that an equal volume of gases at the same temperature and pressure contain equal number of molecules, which means the size of a molecule is so small compared to the volume of the gas. If you look at the 4 balloons on your screen, you will see that they are all 4 different gases, but they have the same volume. So this means they will all have the same number of particles. So the answer to question number 31 will be the size of any gas particle is so small compared to the volume of a gas. It is assumed that no particle has any volume of its own. Now moving on to question number 32. State the equation for the ideal gas law. The ideal gas law is derived from the combined gas law, which further has been derived from the Boyle's law, the Charles law, the Avogadro's law, which you studied in section 13.1. So the ideal gas, when you derive the final equation, it equals to PV equals to nRT, where P stands for pressure, V stands for volume, N stands for the number of moles of the gas, R is the ideal gas constant, it's a fixed constant, and T is the temperature. The temperature is always measured in Kelvin. So the answer for question number 32 will be PV equals to nRT. Number 33. Analyze how the ideal gas law applies to real gases using the kinetic molecular theory. The kinetic theory assumes that the gas particles are so apart that they have almost no influence on the volume of the gas. So if you look at the first box, this is an ideal gas at STP, where STP stands for standard temperature and pressure. The standard temperature is 273 kelvins and the pressure is 1 atmosphere. The second box is a real gas at a low temperature or a high pressure. So when you bring a real gas at STP, it will look something like as the box 3. Now as you start increasing the temperature or decreasing the pressure, a real gas would become similar to an ideal gas. So a real gas behaves most like an ideal gas under conditions that increase the distance and reduce the attraction among gas particles. And the best conditions for that are high temperature and low pressure. Question number 34. Predict the conditions under which a real gas might deviate from an ideal gas situation. Now, a real gas would deviate from an ideal gas behavior in 2 conditions: by bringing the particles closer And this could be done by increasing the pressure. The second situation would be by increasing the attraction forces, and this could be done by lowering the temperature, which eventually would turn the gas into a liquid. So a real gas might deviate from an ideal gas behavior under conditions that decrease the distance and increase the attractions among gas particles, such as low temperature and high pressure. Question number 35. List most common units for each variable in the ideal gas law. The ideal gas law equation is PV equals to nRT, where R is the constant. P stands for pressure, and the common units for pressure are atmosphere, millimeters of mercury, torr, and kilopascals. Volume is liters or milliliters. Temperature is always measured in Kelvin, and the number of moles is by moles. Question number 36. A 2-liter flask is filled with propane C3H8 at a pressure of 1 atmosphere and a temperature of negative 15 degrees. What is the mass of the propane in the flask? First, we will look at what's given. The volume is 2 liters, pressure is 1 atmosphere, temperature is negative 15 degrees Celsius, and we will convert that into Kelvin by adding plus 273. The molar mass of propane will be 3 multiplied by the molar mass of carbon, which is 12, and 8 multiplied by the molar mass of hydrogen, which is 1. And so the molar mass of propane will equal to 44 grams per mole. The ideal gas equation is PV equals to nRT. N represents the number of moles, which can be broken down into mass divided by molar mass. So PV equals to mRT over molar mass. Now if you plug in all the given values, it will be 1 into 2 into 44 divided by 0.0821 multiplied by 258. The final answer would be 4.16 grams of propane.